Have you ever looked up at the night sky and wondered, among all those shimmering stars, whether there is a burning red planet waiting for us to discover it? A world closer to Earth than any other, yet so distant that it takes millions of light years to reach the questions humanity has been asking since the dawn of time. Mars. A name that feels familiar, yet one that hides countless mysteries we still cannot fully unravel. It is not just a planet. It is a love letter from the universe's past, a mirror reflecting the future of humankind, a philosophical question about life and death. Find a quiet place. Let your shoulders relax. Close your eyes if you wish. Let this sound wash over you like the Martian winds that once swept across deep red deserts billions of years ago. Imagine yourself lying on a dune, gazing up at a sky where Earth is nothing more than a faint pale blue dot. On this journey, we will wander together through the deepest valleys, the tallest mountains, and the most wondrous scientific mysteries of Mars. We will not only learn about a planet. We will learn about ourselves, about the origins of life, about what it means to exist in this vast universe. And if this journey feels meaningful to you, if you want to keep exploring the mysteries of the cosmos with me, please like the video and subscribe to the channel. It is not just a simple click. It is your way of saying, I want to understand more. I want to see farther. I want to connect with the universe. And I sincerely thank you for being here, for listening, for allowing me to share these wonders with you. Mars is not just a red dot in the sky. It is a world full of questions. And each question is a doorway, opening toward a deeper understanding of our place in the universe. Now, let us begin with the first question. Why is Mars red? The Romans called it Mars, after their god of war, because its color reminded them of blood and fire. In Chinese culture, it was known as the fire star. For thousands of years, across countless civilizations, humanity has looked up and seen the same mysterious color. Yet it was not until the 20th century that we truly understood why. The answer lies in a single, simple word, rust. Take a slow breath. Think of old iron gates you may have seen, forgotten bicycles left out in the rain, pieces of metal slowly eaten away by time. They all share one thing in common, the reddish-brown color of rust. That is exactly what covers the surface of Mars. According to NASA, the surface of Mars contains extremely high amounts of iron oxide. This is the same chemical compound we call rust here on Earth. Imagine an entire planet, a world spanning 144 million square kilometers, blanketed in a fine powder of rust. The dust particles are so small that they float in the atmosphere, giving Mars its red color not only on the ground, but in its sky as well. But a deeper question follows. How can a planet rust at all? On Earth, iron only rusts when it comes into contact with oxygen and water. It is a process called oxidation. Yet modern Mars is a cold, dry desert, with an atmosphere only about 1% as thick as Earth's, and almost no liquid water on its surface. So how did the iron rust? Scientists believe that around 3 to 4 billion years ago, Mars was a very different place. It had a thicker atmosphere, a warmer climate. And most importantly, it had water, a lot of water. Perhaps enough to form oceans that covered much of the planet's northern hemisphere. Rivers carved through valleys. Lakes shimmered beneath a young sun. During that time, iron in Martian rocks and soil began reacting with oxygen and water. Over millions of years, oxidation continued without pause. Every stone, every grain of dust, every mountain slowly turned the color of rust. It was a quiet, patient process, as if the planet itself were changing its clothes. Dr. Stack Morgan, a planetary scientist at NASA, once said, "The red color of Mars is a fingerprint of a wet past. Every red dust grain is a silent witness to a story of water and air that are now gone." Yet there is something even more intriguing. Mars is not evenly red everywhere. If you look closely at images from spacecraft, you will notice darker regions, gray-blue areas, strange bright patches. This tells us that the surface of Mars is not uniform. It has a complex geological history, with different layers of rock and different minerals, each telling its own story. For example, NASA's Mars orbiter detected deposits of hematite, a crystalline form of iron oxide, in specific regions. Hematite usually forms in the presence of water. This discovery strengthened the idea that Mars once had lakes, and perhaps even seas. An ancient Martian sea, 3.5 billion years ago. Gentle waves lapping against the shore. A sky that may have been slightly bluer than the pink-orange haze we see today. Winds carrying the scent of minerals. Day by day, drop by drop, water evaporated, oxygen reacted with iron, and the planet slowly turned red. This transformation unfolded over billions of years. A shift from a potentially habitable world to a frozen desert. And the red color we see today, it is the color of loss. The color of vanished water. The color of an atmosphere that escaped into space. Carl Sagan, the great astronomer and philosopher, once wrote, "Each planet is a world. Each world has its own story." And the story of Mars is a story of change, of loss, and perhaps, of hope. Because if Mars once had water, if it was once warmer, then perhaps it also once had life. And if life ever existed there, traces of it may still remain, preserved in layers of rock, hidden in caves, locked deep beneath the surface where water still survives as ice. The red of Mars is not just a simple scientific answer about chemistry. It is an invitation. A reminder that planets have lifetimes, that they change, that they age. And perhaps one day, our own Earth will change its color too, and tell a very different story. But before we dive deeper into the mysteries of water and life, another question waits quietly in the dark. If Mars once had water, where did it go? How can a planet lose an entire ocean? Imagine you are holding a full glass of water in your hand. You set it on a table and walk away. An hour later, you come back and notice the water level has dropped slightly. A day later, it is lower still. A week later, the glass is completely dry. The water has evaporated into the air. It is a natural process we all understand. Now, take that same idea and scale it up by billions of times. Instead of a glass, imagine an entire ocean. Instead of a week, imagine millions of years. That is exactly how the water on Mars disappeared, molecule by molecule, drop by drop, in the absolute silence of cosmic time. The evidence for water on Mars is not vague or controversial. It is everywhere, as clear as the wrinkles on an old face. The most recent spacecraft have sent back thousands of images showing undeniable traces of water. There are massive valleys that look exactly like river valleys on Earth, complete with branching tributaries shaped precisely the way flowing water creates them. There are river deltas, where rivers once emptied into seas, with layers of sediment arranged just as water lays down mud and sand. There are even dry channels that look as if water flowed through them just days ago, even though in reality it has been millions of years. Dr. Michael Meyer, the lead scientist of NASA's Mars exploration program, once said, "We are no longer asking whether Mars had water. We are asking how much water there was, how long it lasted, and most importantly, where it went." Scientists estimate that ancient Mars may have had enough water to cover the entire planet to a depth of about 137 meters. If all that water had collected in the northern hemisphere, where the terrain is lower, it could have formed an ocean up to 1.6 kilometers deep, covering about 19% of the planet's surface. That is an enormous amount of water, enough to nearly fill the Mediterranean Sea twice over. So where did all that water go? There are three main paths Mars's water followed, and each one tells a different story of loss. The first path was escape into space. Imagine standing on the highest mountain on Earth. The wind howls around you. But no matter how strong it gets, it cannot blow you into space, because Earth's gravity holds you down. Our atmosphere works the same way, it is held in place by a strong gravitational pull. Mars, however, is smaller than Earth. Its mass is only about 11% of ours. That means its gravity is much weaker, and that creates a serious problem. Around 4 billion years ago, Mars lost something critically important, its global magnetic field. Earth's magnetic field is generated by a spinning, molten iron core deep inside the planet. It creates an invisible shield that protects us from the solar wind, a stream of charged particles blasting out from the sun at speeds of about 400 kilometers per second. Mars was smaller and cooled faster. Its core solidified. Its magnetic field collapsed. And once that shield was gone, the solar wind began slamming directly into the Martian atmosphere. And the water went with it. When sunlight hits a water molecule, it can split it into hydrogen and oxygen. Hydrogen is incredibly light, so light that it can escape Mars's weak gravity and drift off into space. Molecule by molecule, day after day, over millions of years. NASA scientists have explained it this way: we are watching a planet lose its atmosphere in real time. It is a slow but relentless process. Every second that passes, Mars becomes a little drier, a little colder, a little more dead. The second path was freezing at the poles. Not all the water escaped into space. A large portion of it is still there, just in a different form, ice. If you look at Mars's polar regions, where temperatures can drop to -125 degrees Celsius, you will see enormous ice caps. They look like white hats sitting on top of the planet. These caps are not made of water ice alone. They also contain frozen carbon dioxide, forming layered structures that resemble a giant layered cake. Beneath these ice caps, radar satellites have detected ice layers several kilometers thick. In 2018, a study published in a major scientific journal estimated that if all the polar ice on Mars were to melt, it could create a layer of water covering the entire planet to a depth of about 1.5 meters. But there is an even more astonishing discovery. Ice is not only found at the poles. It exists everywhere, even near the equator. It is hidden just beneath the surface, buried under the red dust. The Phoenix lander once dug down and touched ice just a few centimeters below the ground. The Curiosity rover discovered chemically bound water locked inside the molecular structure of rocks. The third path is water hidden underground. And this may be the greatest mystery of all, water that is still there, deep beneath the surface, in liquid form. In 2018, scientists from the European Space Agency announced a shocking discovery. They had found evidence of a liquid water lake beneath the surface near Mars's south pole, about 1.5 kilometers below the ice. This water may remain liquid because of the immense pressure from the ice above it, and possibly because dissolved salts lower its freezing point. Pause for a moment. Let that sink in. Right now, at this very moment, as you are listening to these words, there may be dark, silent lakes existing beneath the surface of Mars. Lakes that have not seen sunlight for millions of years. And where there is water, there may be life. Astronomer Neil Tyson once said, "Water is not just the source of life. It is life." To find water is to find hope. The story of water on Mars is a story of slow disappearance. A planet that once had waves crashing on shores, rain falling from the sky, and rivers carving the land is now reduced to dry scars and silent ice reservoirs. But it is also a story of persistence. Because the water is still there. It has not vanished completely. It is waiting. And the next question follows naturally. If Mars once had water, if it was once warm, could life have ever emerged there? Imagine you are walking along a deserted beach. You look down and notice a seashell. You pick it up, run your fingers over the ripples on its surface, and for a brief moment, you know that something once lived inside it. Maybe hundreds of years ago. Maybe thousands. But life was here, and it left a trace. That is exactly what scientists are doing on Mars. They are strolling across a cosmic shoreline, searching for the seashells of life. So if life once existed on Mars, what traces might it have left behind? To answer that, we first need to understand what life actually is. Not in a philosophical or poetic sense, but in a concrete scientific one. Life, at its most basic form as we know it, needs three things: liquid water, a source of energy, and essential chemical elements such as carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. We already know that Mars once had water. So what about the other two? Energy on ancient Mars. On Earth, most life depends on the sun through photosynthesis. But not all life does. Deep on the ocean floor, where sunlight never reaches, entire ecosystems thrive on chemical energy, energy released by chemical reactions. These organisms live around hydrothermal vents, where hot, mineral-rich water gushes up from beneath the seafloor. Ancient Mars may have had similar environments. We know it once experienced intense volcanic activity. Olympus Mons, the tallest volcano in the solar system, stands as undeniable proof. Where there is volcanism, there is heat. And where there is heat and water, there may be chemically powered life. And of course, there was sunlight. The sun 4 billion years ago was about 25% weaker than it is today, but still strong enough to power photosynthesis, if any organisms had evolved that ability. The chemical ingredients. This is where the story becomes truly fascinating. Since landing in Gale Crater in 2012, the Curiosity rover has analyzed hundreds of rock samples. What it found stunned the scientific community. In 2013, Curiosity analyzed an ancient clay sample drilled from a rock called John Klein. The results showed that it contained all the elements required for life: carbon, hydrogen, oxygen, nitrogen, sulfur, and phosphorus. Even more remarkable, the pH level and mineral composition indicated that this environment was once fresh, neutral water, much like a lake on Earth. Dr. John Grotzinger, the project scientist for the Curiosity mission at the time, announced, "We have found an environment that could have supported life." This is no longer a question of whether Mars was habitable. It is a question of whether it ever actually hosted life. But finding a habitable environment is one thing. Finding evidence of life is something else entirely. Let us return to Earth for a moment. In Western Australia, there are strange, layered rock structures formed by bacteria over billions of years. Some of these formations are as old as 3.5 billion years, making them among the oldest known traces of life on our planet. The incredible thing is that we can see them. We can touch them. We can know that tiny microorganisms once lived, breathed, and left behind these stone structures like letters sent to the future. On Mars, scientists are searching for similar signs. A rover landed in Jezero Crater in 2021, equipped with the most advanced instruments ever sent to another planet. It can analyze chemical compositions at the molecular level. It can search for organic molecules, complex carbon-based compounds often associated with life. And it has found some promising clues. In September 2022, it collected a rock sample from the area. Analysis revealed high concentrations of organic molecules. This suggests that long ago, sand, mud, and salts were deposited here under conditions that could have supported life. It is astonishing that we can pick up a sample and find it may contain ancient organic molecules. But there is a major problem. Organic molecules do not automatically mean life. They can also be produced by non-biological processes, such as meteorite impacts or natural chemical reactions. To prove life, we need clearer evidence. There is another clue, one that drifts through the thin Martian air itself: methane. On Earth, most methane is produced by living organisms, bacteria in soil, in the guts of animals, in wetlands. It is considered a potential biosignature. Curiosity has detected sudden, unexplained spikes of methane in the Martian atmosphere. At times, the concentration jumps to 10 times its usual level, then drops again. This suggests that methane is being released from somewhere, possibly from underground. But methane can also be produced by geological processes, such as reactions between rock and hot water. For now, we cannot be certain. Dr. Chris McKay, a planetary scientist at NASA who has spent his entire career studying the possibility of life on Mars, once said, "Every new discovery on Mars brings us closer to the answer, but the final answer remains just out of reach." That is the beauty, and the frustration, of science. If life did exist, what would it have looked like? Close your eyes. Imagine Mars 3.5 billion years ago. A calm lake, surrounded by distant volcanoes. Clear water, gently warmed by a young Sunday. And somewhere in that water, there may have been a simple cell. Just one cell. No eyes, no brain, no awareness. But it was alive. It absorbed nutrients. It copied itself. It evolved. It did not know that its planet was dying. That the magnetic field was fading. That the water was slowly disappearing. That within a few 100 million years, everything would turn into desert. Perhaps life on Mars never advanced beyond simple bacteria. Perhaps it lasted only a few 100 million years before the environment became too harsh. Perhaps the last organisms retreated deep underground, where water still remained, and maybe, just maybe, their descendants are still there, in the darkness, waiting. Or perhaps life never began at all. Perhaps all the conditions were ready, but that mysterious spark, whatever it truly is, never appeared. Carl Sagan once said, "If there is life on Mars, then the question of the origin of life becomes much more complex and far more wonderful. If there is not, then our loneliness in the universe becomes deeper." But the search for life is not only about finding microbes on Mars. It is about understanding who we are, where we came from, and whether life is a rare miracle or an inevitable outcome of the universe itself. And to understand that more deeply, we need to explore another side of Mars, its strange and dramatic landscape, where clues to the planet's violent and extraordinary past are written into the ground itself. So what does Mars really look like when we take a closer look? The surface of Mars stretches endlessly to the horizon, a world of strange contrasts. On one side rise mountains taller than anything on Earth. On the other lie vast chasms so deep they could swallow the entire Himalayas. Mars has only 38% of Earth's gravity. If you weigh 70 kilograms on Earth, you would weigh just 26 kilograms on Mars. You could jump 3 times higher. You would move as if you were floating inside a dream. And in that dream, you would see landscapes that feel almost impossible. Let's begin with a number the human mind struggles to grasp, 21.9 kilometers. That is the height of Olympus Mons, the tallest mountain in the entire solar system. For comparison, Mount Everest, the highest peak on Earth, rises only 8.8 kilometers. Olympus Mons is nearly 2.5 times taller. It is so high that if you stood on its summit, you would be above most of Mars's atmosphere. You could see the curve of the planet. Above you, the darkness of space would begin to take over. But height is not the only thing that makes Olympus Mons extraordinary. It is about 600 kilometers wide, roughly the size of the state of Arizona. If you stood at its base and looked up, you would not be able to see the summit, not because it is too far away, but because the slope is so gentle that the peak lies beyond the horizon. This is a colossal volcano, built from millions of years of lava eruptions. Layer upon layer piled up, each flow cooling and hardening, creating a mountain that feels like it belongs in the dreams, or nightmares, of giants. So why could Olympus Mons grow so tall? The answer lies in weak gravity and the absence of plate tectonics. On Earth, tectonic plates move, carrying volcanic hot spots along with them and forming chains of volcanoes like the Hawaiian Islands. But on Mars, the plates do not move. The crust stays still. That means the same hot spot erupted in the same place for billions of years, building the mountain higher and higher, until it reached for the sky. One planetary volcanologist explained it this way: Olympus Mons is a monument to the power of time. On Earth, we cannot have volcanoes like this because our planet is too active. But Mars, in its geological stillness, created masterpieces that simply cannot exist anywhere else. Now, drift eastward. Let sunlight cut through the thin atmosphere at a low angle, painting the landscape in soft shades of orange and pink. Slowly, a vast scar opens before you, tearing across the planet's surface. This is Valles Marineris, named after the Mariner 9 spacecraft, the first to orbit Mars in 1971 and reveal this immense canyon system. Once again, the numbers are staggering. It stretches about 4,000 kilometers long, up to 200 kilometers wide in places, and plunges as deep as 7 kilometers. If it were placed on Earth, it would run from the east coast of the United States all the way to the west. Stand at the edge of Valles Marineris and look down. The canyon floor is so far below that it fades into a dusty haze. The walls drop almost straight down, with layers of rock stacked like pages in a history book, each layer telling a story from a different era of the planet's past. Scientists believe Valles Marineris formed mainly through tectonic forces, as the Martian crust cracked and stretched when the Tharsis region, home to Olympus Mons and other massive volcanoes, bulged upward from volcanic activity. Imagine inflating a balloon covered in dried paint. As the balloon expands, the paint cracks. That is essentially what happened to Mars. But there is another detail that makes Valles Marineris even more mysterious. There is evidence that water once flowed through parts of it. Some branches of the canyon system resemble channels carved by running water. Long ago, when Mars was warmer and wetter, enormous rivers may have thundered through this valley, creating waterfalls taller than any that ever existed on Earth. Close your eyes for a moment and imagine the sound. Water crashing down a 7-kilometer drop. The roar echoing across a canyon 200 kilometers wide. A symphony of nature that no human ear has ever heard. There is something else about Mars that many people do not realize. Its two hemispheres are completely different. The southern hemisphere is high, rough, and heavily cratered, much like the Moon. Some of these impact craters are about 4 billion years old, preserved almost perfectly because of the lack of geological activity and erosion. The northern hemisphere is low, flat, and smooth, resembling the floors of ancient oceans. The average elevation difference between the two hemispheres reaches about 5 kilometers. This is one of the greatest mysteries in planetary science. Why would a single planet have two faces so utterly different? One leading hypothesis suggests that Mars was struck by a massive object, possibly as large as Earth's moon, around 4 billion years ago. The impact, hitting at an angle, may have stripped away much of the northern hemisphere's crust, leaving behind a colossal scar more than 10,000 kilometers across. If this impact hypothesis is correct, Mars experienced one of the most violent events in the history of the solar system. It may have melted vast portions of the surface, created oceans of magma, and possibly contributed to the planet losing its magnetic field. Now, travel all the way to the far north of Mars. Here, winter temperatures can drop to minus 125 degrees Celsius. Vast polar ice caps stretch for hundreds of kilometers, shimmering under the faint light of the distant sun. These ice caps are not static. They move to a strange and beautiful rhythm. In winter, carbon dioxide from the atmosphere freezes and falls like snow, forming thick layers of dry ice several meters deep. In spring, that dry ice sublimates, turning directly from solid to gas, creating dramatic gas eruptions that look like alien geysers. Spacecraft have captured stunning images of this process. Dark spots appear on the white ice as carbon dioxide gas bursts upward, carrying dust and sand with it, forming patterns that look like abstract art made by nature itself. Fans, branching shapes, designs no human artist could ever invent. Across the surface of Mars, thousands of impact craters mark the planet, scars left behind by billions of years of bombardment from asteroids and meteoroids. But these craters are more than simple dents. They are windows through time. When a space rock strikes the surface, it digs up material from deep below, exposing rocks that may have been buried for billions of years. Scientists study these craters to understand Mars's internal structure, much like archaeologists excavate layers of soil to uncover human history. Gale Crater, where the Curiosity rover is exploring, contains a central mountain about 5 kilometers tall called Mount Sharp. This mountain is actually made of sedimentary layers stacked over millions of years, shaped by wind, water, or both. Each layer is a chapter in the story of Mars's climate. Curiosity is slowly climbing this mountain, analyzing each layer, reading each page of that ancient book. Every discovery adds another piece to the larger picture of how Mars has changed over time. Take a deep breath. Feel time itself, not measured in seconds or minutes or hours, but in billions of years. Time long enough to build the tallest mountains, carve the deepest valleys, and leave marks that will never fully fade. The terrain of Mars is not just beautiful. It is a record, a diary written in rock and ice, in wind and time. And as we learn to read it, we begin to understand not only Mars, but all rocky planets, including our own. But there is one more factor that makes Mars even more unique. It is not just its landscape, but the way time itself flows differently on the red planet. So how long is a day, a year on Mars, and how does that shape everything we see? Imagine opening your eyes in the morning. Light spills through the window. You glance at the clock and know it is time to wake up. But that clock is ticking to Earth's rhythm, 24 hours in a day, 365 days in a year. It is a rhythm your biology has adapted to over millions of years of evolution. But if you woke up on Mars, time would be playing a very different tune. On Mars, scientists do not really talk about a day. They talk about a sol, a word that comes from Latin, meaning the sun. One sol lasts 24 hours, 39 minutes, and 35 seconds in Earth time. Just about 40 minutes longer than an Earth day. It sounds like a tiny difference, but think about what that really means. If you lived on Mars and tried to keep an Earth clock, you would drift by almost 5 hours every week. After a month, you would be off by nearly 20 hours. Morning would slowly turn into evening. Your sleep would fall apart. Your body would feel like it was stuck in permanent jet lag. This is not just theory. Scientists and engineers who operate Mars rovers actually live on Mars time. They call it exactly that. Mars time. Every workday is slightly longer. Every week, their schedule slides farther out of sync with the rest of the world. Here is the surprising part. Those extra 40 minutes might actually be perfect for humans. Some studies suggest that the natural human circadian rhythm is a little longer than 24 hours, somewhere between 24.2 and 24.5 hours. In other words, in a strange way, humans might adapt to a Martian day more easily than we expect. But time becomes truly strange when we talk about a year. Mars orbits the Sun on a much longer path than Earth. A Martian year lasts 687 Earth days, or 668 Martian sols. Nearly twice as long as a year on Earth. Close your eyes and imagine that. If you were born in the spring on Mars, you would wait almost 2 Earth years before seeing spring again. A child who is 10 years old by Earth time would be only about 5 years old by Martian time. And yet, Mars still has 4 seasons, just like Earth. Why? Because its axis is tilted by about 25 degrees, very close to Earth's 23.5 degrees. That tilt causes different hemispheres to lean toward or away from the Sun, creating seasons. But there is one crucial difference. Mars does not travel around the Sun in a perfect circle. Its orbit is much more elliptical than Earth's. That means the distance between Mars and the Sun changes dramatically over the course of a year. At its closest point, Mars is about 206 million kilometers from the Sun. At its farthest, it is about 249 million kilometers away. That is a difference of 43 million kilometers, almost the entire orbit of Mercury. This makes Martian seasons strangely unbalanced. Summer in the southern hemisphere, which happens when Mars is closest to the Sun, is short and extremely hot by Martian standards. Winter in the southern hemisphere is long and brutally cold. In some regions, the temperature difference between summer and winter can reach 160 degrees Celsius. And this is where time on Mars becomes truly eerie, and a little frightening. When Mars approaches the Sun during southern summer, temperatures rise quickly. The air warms, winds grow stronger, and those winds lift dust. On a planet that is basically a dry desert, with no trees or water to hold the soil down, dust rises easily. Small dust storms merge into larger ones. And sometimes, for reasons scientists still do not fully understand, those storms grow into global dust storms that swallow the entire planet. In 2018, one of these global dust storms covered Mars for months. The sky turned dark reddish-brown. Sunlight was blocked. The Opportunity rover, which had worked on the Martian surface for 14 years, far beyond its original 90-day mission, could no longer recharge its solar panels. It sent its final signal on June 10, 2018, and then fell silent forever. It was a heartbreaking moment for the planetary science community. A small, lonely machine slowly dying in the darkness of a dust storm, millions of kilometers from home. Dr. Steve Squires, the principal investigator of the Opportunity mission, once said, "Opportunity taught us that time on Mars is not like time on Earth. It has harsher seasons, more violent storms, but also moments of breathtaking calm that no other planet can match." Now imagine standing on the surface of Mars at sunset. The sun, about 2/3 the size it appears from Earth, slowly sinks toward the horizon. But the colors are completely reversed. On Earth, sunsets glow red and orange because blue light is scattered away by our thick atmosphere, leaving red light behind. On Mars, the daytime sky often looks peach or pale orange because of red dust in the air. And at sunset, the sky around the sun turns blue. Yes. Blue sunsets. The Curiosity rover has captured stunning images of this. A soft blue halo surrounding the setting sun. Tiny dust particles in the Martian atmosphere scatter blue light in a very particular way, creating this otherworldly effect. And at night, the Martian sky becomes a dazzling blanket of stars. There is no light pollution. No thick cloud cover. Just a thin, thread-like atmosphere. The stars shine sharply, without twinkling, because there is not enough air to disturb their light. If you look up at the right moment, you might spot a small bluish dot. Earth. The world we call home, reduced to a faint point of light, just one among countless stars. But two stars race across the Martian night sky. Mars's two moons, Phobos and Deimos. Unlike Earth's large, bright moon, Mars's moons are small and dark. Phobos, the larger one, is only about 22 kilometers across. You could drive across it in a few hours. Deimos is even smaller, just 12 kilometers wide. What makes Phobos extraordinary is its speed. It orbits Mars in just 7 hours and 39 minutes, faster than Mars rotates. That means from the surface of Mars, Phobos rises in the west and sets in the east, the opposite of almost everything else in the sky. It rises and sets twice during a single Martian day. Picture yourself sitting on a rock, watching Phobos streak overhead, an irregular, potato-shaped chunk of rock so close you could see its craters with the naked eye. It moves fast enough that you can watch it travel across the sky in real time, like an artificial satellite, but far larger and far closer. And here is the sad detail. Phobos is slowly falling toward Mars. Every century, it gets about 1.8 meters closer. In roughly 50 million years, it will either crash into the Martian surface, carving a massive crater, or be torn apart by tidal forces and form a ring of debris around the planet. Time on Mars is not just about seconds, minutes, and hours. It is about the rhythm of another world, seasons that last twice as long, haunting blue sunsets, backward flying moons, and storms that can engulf an entire planet. Carl Sagan once wrote, "Time is a river in which I go fishing. I drink from it, but while I drink I see the sandy bottom and detect how shallow it is. Its thin current slides away, but eternity remains." On Mars, the river of time flows to a different rhythm. But it still flows, endlessly, carrying stories of the past and mysteries of the future. And now we have to ask, with everything we know about Mars, its water, its landscapes, its time, why do we care so much about it? Why do humans feel such a powerful pull to go there? There is something within us, something ancient and hard to explain, that urges us to want to know what lies beyond. Our ancestors stood at the edge of the sea and wondered, what is out there? Then they built boats. They set sail. They discovered. And now, we stand on the shore of a different ocean, an endless cosmic sea. We look up at Mars. Take a slow breath out. Feel the weight of that question. Because the answer is not just about science or technology. It is about human nature. About hope. About survival. And about something even deeper, a longing to connect with the universe itself. There is a theory in evolutionary biology that humans carry an exploration gene, linked to novelty-seeking, risk-taking, and migration. People who carry this trait tend to be unable to stay still. They want to see what lies beyond the mountain. They want to know what is past the horizon. These are the very people who led humanity out of Africa tens of thousands of years ago, spreading across the earth, crossing deserts, oceans, and mountains. Now, we have reached the final frontier of our home planet. There are no continents left to discover. No unmapped seas. So where does that exploration gene lead us next? To the stars. Mars is the next step. Not because it is easy, but because it is possible. Because it is close enough. Because it is similar enough to Earth that we can imagine living there. But there is a deeper reason, a philosophical and even spiritual one. Throughout human history, we have asked the same question. Is anyone else out there? Are we the only life in the universe? This is not just a scientific question. It is a question of meaning, of purpose, of our place in the bigger picture. And Mars may give us an answer. If we find evidence of life on Mars, even fossilized microbes, even traces of simple cells from billions of years ago, it would be one of the most important discoveries in human history. It would mean that life is not a lucky accident that happened only once on Earth. It would mean that under the right conditions, life emerges as a natural outcome of the laws of physics. It would mean that in the deep reaches of the universe, with billions of planets and trillions of stars, we may not be alone. Dr. Chris McKay, an astrobiologist at NASA who has spent more than 40 years studying the possibility of life on Mars, once said, if we find a microbe on Mars that has an origin independent of life on Earth, that is when everything changes. We will know that the universe is full of life. And suddenly, we will no longer be lonely children in the dark. But there is another scenario, a more unsettling one. What if we find nothing? What if Mars, a planet that once had water, once was warm, once had all the right conditions for life, is still lifeless? That would mean life is incredibly rare. It might mean that we truly are alone in this vast universe. Both answers are profound. Both would change how we see ourselves. But there is an even more practical reason, one that many scientists and thinkers consider the most important of all, the survival of our species. Think about this for a moment. Right now, all of humanity, nearly 8 billion people, all cultures, all history, all art, all knowledge, exists on a single planet. We are like eggs placed in one basket. What happens if a large asteroid strikes Earth? What happens if a truly catastrophic global pandemic emerges? What happens if we destroy ourselves through nuclear war or climate collapse? The answer is simple and terrifying. Everything disappears. All that we have built, all that we have learned, all that we love, gone. Stephen Hawking, one of the greatest physicists of all time, warned us, I believe that the long-term future of the human race must be in space. It will be difficult to avoid disaster on planet Earth in the next 100 years, let alone the next 1,000 or million years. The human race should not have all its eggs in one basket, or on one planet. Mars is the second basket. It is our chance to spread humanity across two worlds. This is not about abandoning Earth, never that. It is about making sure that if the worst happens here, our civilization continues there. There is another reason, one that is harder to measure but no less important. Space exploration inspires us. In July 1969, when Neil Armstrong stepped onto the moon, more than 600 million people around the world watched live. For a brief moment, people of every nation, every culture, every religion looked at the same screen and felt something together. Pride. Awe. Hope. Close your eyes for a second and imagine the day the first human steps onto Mars. A single person, maybe American, maybe Chinese, maybe from an international coalition, steps out of a spacecraft and places their foot on the red dust of a new world. They speak a few words, heard across the earth. And in that moment, billions of people look up and feel the same thought. We did it. Humanity did it. That is the power of exploration. It reminds us of what we can achieve when we work together. It lifts us out of our daily arguments and shows us a much bigger vision. And let us not forget the practical benefits. History shows that great explorations always lead to unexpected technological breakthroughs. The Apollo program that took humans to the moon produced thousands of inventions and innovations, from compact computers to new materials, from medical technologies to water filtration systems. Many of the technologies we take for granted today, including advances in microchips and telecommunications, trace their roots back to the space race. Sending humans to Mars will force us to solve some of the hardest problems imaginable. How do we grow food in extreme environments? How do we fully recycle water and air? How do we protect humans from radiation? How do we build durable structures with limited resources? The solutions to these problems will not only help us on Mars. They will transform how we live on Earth, especially in a world facing climate change and resource scarcity. But perhaps, at the deepest level, we want to go to Mars for a simpler reason. Because we dream. Humans are the only creatures on Earth who can look up at the night sky and ask, what is out there? We are the only creatures who can imagine worlds we have never seen. We are the only creatures who can hope, plan, and work toward a future we may not live long enough to witness. Carl Sagan, in his timeless book, Cosmos, wrote, Mars has become a kind of mythic new world. A place of hope and possibility. If our ancestors had not looked beyond their grasslands and wondered what lay beyond, we would never have discovered the world. And now, our grassland is the entire planet, and we are looking beyond it. Take a deep breath. Feel the weight of this moment in history. We are living in the generation that can do this. We have the technology. We have the knowledge. We have the will. The first human to walk on Mars may already have been born. They might be a child right now, looking up at the night sky with wide eyes, wondering, could I go there? And the answer is yes. Not easily. Not quickly. But yes. Yet before we can reach Mars, we must understand the challenges, the real dangers humans will face on the longest journey in our history. So how hard is it to get to Mars, and what are the main dangers we must overcome? If you are preparing for a journey, not a weekend trip, not a vacation that lasts a few weeks, but a journey that will take at least 2 years, where there is no turning back, no rescue call to make, and every mistake could be fatal. A trip to Mars is unlike any journey humanity has ever taken. Take a slow breath. Feel the air around you, air rich in oxygen, with the right pressure, a comfortable temperature. Everything we take for granted here will not exist on the way to Mars. Every breath, every drop of water, every calorie of energy must be carried with you or created from scratch. Let's start with distance. How far away is Mars? The answer is not simple, because both Earth and Mars are constantly moving around the Sun. Sometimes they are closer together, sometimes they are on opposite sides of the Sun. At its closest point, Mars is about 54.6 million kilometers from Earth. At its farthest, when the two planets are on opposite sides of the Sun, that distance can stretch to around 401 million kilometers. Let that sink in. 54.6 million kilometers is the minimum distance. For comparison, the Moon, the farthest place humans have ever traveled, is only about 384,400 kilometers away. Even at its closest, Mars is more than 142 times farther than the Moon. Light travels at about 300,000 kilometers per second, the fastest speed in the universe. Light from the Moon takes about 1.3 seconds to reach Earth. But light from Mars takes around 3 minutes at its closest, and nearly 22 minutes at its farthest. That means if you are on Mars and you call home, you have to wait at least 6 minutes to hear a reply. Real-time conversations are impossible. And for our spacecraft, machines far slower than light, the journey to Mars takes between 6 and 9 months with current technology. 6 to 9 months inside a small metal box, drifting through empty space. But you cannot just decide to go to Mars whenever you want. You have to wait for the right moment. Because of the planet's orbits, the optimal launch window, the time when Earth and Mars are aligned for the shortest and most efficient journey, opens only once every 26 months. Miss that window, and you wait more than 2 years. This means every Mars mission must be planned years in advance. And once you leave, you cannot come back until the next launch window opens. That means staying on Mars for at least 18 to 20 months before you can even begin the journey home. Altogether, a round trip to Mars takes a minimum of 2 to 3 years. Dr. Dava Newman, former deputy administrator of NASA, explained it this way. This is the biggest commitment humans have ever made in space. Apollo astronauts were only days away from Earth. Astronauts on the International Space Station can return home within hours if needed. But with Mars, there is no abort button. Once you commit, you have to go all the way. Now imagine you are inside the spacecraft, drifting through space. Outside the window is absolute darkness. But something is constantly hitting you, something you cannot see, smell, or feel, until it is too late. Radiation. On Earth, we are protected by 2 invisible shields, the planet's magnetic field and its thick atmosphere. Together, they block most dangerous cosmic and solar radiation. In deep space, there is no shield. You are directly exposed to galactic cosmic rays, ultra-high energy particles from distant supernova explosions, traveling at nearly the speed of light, powerful enough to pass through spacecraft walls and human bodies. When one of these particles passes through your cells, it can damage DNA. Sometimes your body repairs the damage. Sometimes it cannot. And when it cannot, the result can be cancer. Then there are solar storms. Occasionally, the sun releases massive bursts of charged particles. If you are caught in one of these storms in deep space without adequate protection, you could receive a radiation dose high enough to cause acute radiation sickness within hours. Scientists estimate that during a round trip to Mars, an astronaut could receive up to 300 times the radiation you experience on Earth in a single year. This increases cancer risk by about 5%, shortens lifespan, damages the eyes, causing cataracts, and may affect the brain, leading to problems with memory and decision-making. Now imagine floating inside the spacecraft. No gravity. No up or down. At first, it might feel exciting. But after a few weeks, your body begins to change, and not in a good way. Muscles shrink. Without gravity to push against, muscles begin to waste away. Astronauts can lose up to 20% of their muscle mass on long missions. Bones weaken. Your body constantly rebuilds bone, breaking old bone down and building new bone up. In microgravity, breakdown happens faster than rebuilding. Astronauts can lose 1 to 2% of bone mass per month in certain areas. After 9 months, that is 9 to 18%, equivalent to 10 to 20 years of natural aging. Vision changes. In microgravity, fluids shift toward the head, increasing pressure on the eyes. Many astronauts report worsened eyesight after long missions, and some of these changes are permanent. The immune system weakens. Studies show that microgravity suppresses immune function, making astronauts more vulnerable to infections. Even the heart changes shape. Without gravity, the heart does not have to work as hard to pump blood, so it weakens and becomes rounder. And here is the problem. All of this happens during the flight. Then you arrive at Mars, where gravity is only 38% of Earth's, and you must start working immediately. There is no time to rest. You have to build habitats, set up equipment, explore, all while your body is at its weakest. NASA requires astronauts to exercise at least 2 hours every day to counter these effects. But even with intense training, the decline cannot be completely stopped. Yet the greatest challenge may not be physical. It is psychological. Close your eyes for a moment. Imagine living in a small room with 5 or 6 other people. You cannot leave. You cannot take a walk. You cannot meet anyone new. You eat the same food every day. You see the same faces every day. And outside the window, there is only darkness and death. This lasts 6 to 9 months. Then you arrive on Mars, knowing you must stay there for at least 18 more months before you can even begin the journey home. And the trip back takes another 6 to 9 months. There is no wind in your hair. No smell of forests or oceans. No birdsong. No blue sky. No warm Sunday. Everything the human brain evolved to crave over millions of years is gone. Studies of isolated environments, Antarctic research stations, submarines, and Mars simulations show that people can develop what psychologists call third-quarter syndrome. About 2/3 of the way through a mission, many experience depression, irritability, withdrawal, and loss of motivation. Conflicts between crew members can grow. Small disagreements can turn into major resentments when there is no escape from one another. And after all of that, after 6 to 9 months in space, after radiation and microgravity, after surviving the psychology of isolation, you face the most dangerous challenge of all, landing. NASA engineers call it the 7 minutes of terror. As a spacecraft approaches Mars, it is traveling at about 21,000 kilometers per hour, more than 16 times the speed of sound. It must slow to zero in just 7 minutes. The problem is Mars' atmosphere. It is too thin to slow you down effectively, but thick enough to create extreme friction and heat. It sits in a dangerous middle zone, not thick enough for Earth-style parachutes, not thin enough to ignore. And during those 7 minutes, because of signal delay, there is no way to control the spacecraft from Earth. It must operate completely autonomously, making thousands of decisions in real time. The statistics are sobering. About half of all missions to Mars have failed, many during landing. And those were robots. When it comes to humans, real lives, the risk must be reduced to nearly zero. Take a deep breath. Feel the weight of all these challenges. Radiation. Microgravity. Isolation. Distance. Landing. Each one is difficult on its own. All of them must be solved at the same time. But here is the remarkable thing about humanity. We do not give up. We look at the hardest problems and say, we will figure this out. And we are figuring it out. Day by day, experiment by experiment, mission by mission, we are getting closer. SpaceX is developing Starship. NASA is building the Space Launch System. Private companies, government agencies, and scientists around the world are working relentlessly. Carl Sagan once said, "Sometimes I think we are too busy with problems on Earth to think about space. But then I remember that space is where we will find our future." So if we overcome all these challenges, if we reach Mars, what will life be like there? How could humans survive, and even thrive, on a world so alien? When you finally set foot on Mars, the 6 to 9 month journey is over. The 7 minutes of terror during landing have passed. You are alive. But now, the real challenge begins. You look through the visor of your helmet and see a red desert stretching all the way to the horizon. A peach-colored sky. The atmospheric pressure is only 0.6% of Earth's, roughly equivalent to standing at an altitude of 35 kilometers on Earth, where the blood in your body would begin to boil. Temperatures swing from -125 degrees Celsius at night to as warm as 20 degrees Celsius during the day near the equator, but the average temperature is around -63 degrees Celsius. And you have to live here. Not for a few days. Not for a few weeks. But for years. Maybe for the rest of your life. On Mars, the atmosphere is 95% carbon dioxide, with only 0.13% oxygen. One unprotected breath on Mars would be your last. But humans are extraordinary adapters. We have survived in the Sahara Desert, in the frozen cold of Antarctica, deep underground in caves, and on the highest mountains. And now, we will learn how to live on another planet. The first thing you need is shelter. Not just a place to sleep, but a complete environment that can sustain life. Scientists have proposed many ideas. Inflatable modules are lightweight structures that can be packed tightly inside spacecraft and then expanded on the Martian surface. NASA has tested this technology with the Beam module on the International Space Station. These modules can be made from advanced materials, multilayer Kevlar fabrics that resist radiation, protect against micrometeorites, and hold internal pressure. Lava tubes are natural tunnels formed by ancient lava flows. They could provide natural shielding from radiation and maintain more stable temperatures. Spacecraft have already detected hundreds of potential lava tubes on Mars, some large enough to house entire cities. Three-dimensional printing with regolith uses Martian dust and soil as raw material to print structures. Robots could be sent ahead to build habitats before humans arrive. Experiments on Earth have shown that Martian-like soil can be heated and turned into strong, durable construction material. Shelter is not just about four walls. It has to be a miniature ecosystem, a small world within a vast one. It must have the right pressure, the right temperature, the right mix of gases, and the right amount of radiation filtered out. Inside this shelter, pressure must be maintained at Earth-like levels, or at least within a safe range. Temperature must be controlled. Humidity adjusted. And the air must be continuously filtered and regenerated. On Earth, we breathe without thinking. We drink water without worry. But on Mars, every breath and every drop of water must be produced or recycled. We know there is ice on Mars, at the poles and even beneath the surface in many regions. This ice can be mined, melted, and purified. More importantly, every single drop of water must be reused. Water from sweat, breath, and even urine must be collected and processed. It sounds unpleasant, but this is already reality on the International Space Station, where astronauts joke that today's urine is tomorrow's coffee. One astronaut once said, "Water on the space station is as precious as gold." Every drop is tracked, recycled, and reused. On Mars, it will be even more valuable. You cannot bring enough food for years. It is too heavy. It takes up too much space. So you have to grow your own food. But how do you grow plants on a dead planet? Scientists have experimented with simulated Martian soil and discovered both encouraging signs and serious challenges. Mars soil contains many minerals plants need: magnesium, sulfur, and calcium. But it also contains perchlorates, toxic compounds for humans. The soil must be treated before use. On top of that, it lacks nitrogen, an essential nutrient for plant growth. In novels and films, astronauts grow potatoes using human waste as fertilizer mixed with Martian soil. While the story is fictional, the science behind it is real. Experiments at Wageningen University in the Netherlands have shown that tomatoes, beans, and even carrots can grow in simulated Martian soil after the right nutrients are added and perchlorates are removed. But there is an even better method: hydroponics, growing plants in nutrient-rich water without soil. Or aeroponics, where plant roots are misted with nutrients. These systems use water far more efficiently and can be controlled much more precisely. Close your eyes and imagine a greenhouse on Mars. Sunlight, slightly dimmer than on Earth but still enough, shines through transparent panels. Inside, rows of lush green plants sway gently in the airflow from the ventilation system. The smell of soil, the smell of life. A piece of Earth on an alien world. Everything on Mars, from life support systems to heating to communication to oxygen and water production, requires energy. A lot of energy. Solar power is one option. Mars receives about 43% of the sunlight Earth does. That means solar panels are less efficient, but they still work. Robotic probes have operated entirely on solar power for years. The problem is dust storms. When dust covers the panels, they stop working. And as we have seen, a global dust storm can last for months. Nuclear power may be a more reliable solution. Radioisotope thermoelectric generators provide steady energy regardless of weather or time of day. To power a human settlement, a small compact nuclear reactor may be needed. NASA and the United States Department of Energy have developed the kilopower reactor prototype, a compact system capable of delivering 10 kilowatts of continuous power for 10 years. On Earth, we are used to instant communication. You send a message and get a reply right away. You make a call and someone answers. On Mars, everything slows down. At closest approach, a signal takes 3 minutes to travel from Mars to Earth, and another 3 minutes for the reply to come back. That is a 6-minute delay. At the farthest distance, it can take 44 minutes. Imagine calling home. You say, "Hi Mom, I miss you." Then you wait. 22 minutes pass in silence. Then you hear her voice, "I miss you too, sweetheart. Are you okay?" You reply, "I'm okay, Mom. I just wanted to hear your voice." And then another 22 minutes pass. There are no natural conversations. Every interaction becomes a kind of letter. You record your message, send it, and wait for a response. But there is something beautiful about this. It forces you to think about what you want to say. It makes every word more meaningful. It turns communication into an art that has been mostly lost in the age of instant messaging. But life on Mars is not just about physical survival. It is about creating a society, a culture, a reason to live. The first Martian settlers will have to build new rules, new rituals, new ways of living together. They will need to find meaning in an environment where every day is a fight to stay alive. There will be holidays. Maybe a celebration of the first landing. Maybe a day to remember those who were lost. Maybe festivals when the first crops are harvested. There will be art. Music played inside pressurized modules. Paintings of blue sunrises and red sunsets. Poetry about loneliness and hope. There will be love. People will fall in love. There may even be children, the first humans born beyond Earth. True Martians. Carl Sagan once wrote, "Imagination will often carry us to worlds that never were. But without it we go nowhere." On Mars, imagination will not be just entertainment. It will be survival. The ability to envision a better future, a stronger community, a world where humanity does not merely endure but thrives. And here is a strange thought. People born on Mars will be different from us. In lower gravity, their bones and muscles will develop differently. They may be taller, thinner. Their hearts may adapt to lower pressure. But more deeply, their psychology will be different. To them, Earth will be a myth, a lush blue world of vast oceans and blue skies, a place they have only seen in pictures and videos. Mars will be home. Red sand, pink skies, and gentle gravity, that will be their normal. And perhaps one day, if they visit Earth, they will feel heavy, crushed by gravity 2.6 times stronger than what they have known. The blue sky may seem strange to them. The oceans may terrify them with their unimaginable volume of water. In one generation, maybe just one generation, humanity could split into two branches, Earth humans and Mars humans. From the same origin, shaped by different worlds. So who do we want to be? Brave explorers? Patient builders? Careful guardians? Or all of them at once? And as we look even further into the future, an even deeper question emerges. Can we make Mars more like Earth? Can we transform an entire planet? Imagine standing on a hill on Mars, staring out toward the horizon. But instead of red sand and a pink sky, you see green grass carpeting the valley below. A narrow stream winds through the fields. Trees rise tall around you. And you do not need a helmet. You breathe Martian air straight into your lungs. The wind moves through your hair. The sun, smaller but still warm, rests its heat on your face. This is not science fiction. This is terraforming Mars, the art and science of transforming an entire planet so it can support human life without protective suits. Take a deep breath. Feel the weight of that idea. Because this is not only about technical capability. It is about ethics, about philosophy, about whether we have the right to change an entire world. The idea of terraforming Mars is not new. Astronomer Carl Sagan talked about it as far back as the 1970s. And in recent years, as our understanding of Mars has deepened, the concept has shifted from pure science fiction into a genuine theoretical possibility. But terraforming Mars is not simple. It requires three fundamental changes: raising the temperature, thickening the atmosphere, and creating oxygen. Each step is a monumental challenge. All of them must happen in a specific sequence, over a span of time that could stretch across centuries, even millennia. And this is where the story becomes more complicated. Suppose we could do it, suppose we had the technology, the resources, and the time. The deeper question is this: should we? If life exists on Mars, even microscopic organisms living deep underground, do we have the right to transform the entire planet and possibly wipe it out? Some scientists argue that we have a moral responsibility to search for Martian life first. If we find it, we must protect it, study it, understand it. Because it could be only the second form of life humanity has ever known. Others, like Elon Musk, argue that making Mars habitable is essential for the long-term survival of humanity, and that the benefits of becoming a multiplanetary species outweigh the risks of harming potential microbial life. Then there is the deeper philosophical view. Mars, exactly as it is now, has a beauty of its own. Vast red deserts, a soft pink sky, absolute silence, all of it carries a quiet kind of grandeur. By changing it, are we destroying a natural masterpiece? Philosopher Robert Sparrow once wrote, "There is an arrogance in believing that we can and should reshape entire planets." Mars is not ours to change. It exists for itself, with its own intrinsic value, whether we need it or not. Others push back. Planets are not conscious. They do not care whether they are deserts or forests. But humans, we care. We are the only beings in the solar system capable of appreciating beauty, creating art, living and loving. And if we can spread life, consciousness, and beauty to another world, is that not something good? Take another deep breath. Think about time. The people who begin the terraforming of Mars will never see the result. Their children will not see it. Even their great-grandchildren, generations later, may never see it. This is not a project for individuals, not for a single generation, but for an entire species. It demands a vision and a commitment beyond anything humanity has ever attempted. The pyramids of Egypt took decades to build. Gothic cathedrals in Europe took centuries. But terraforming Mars could take thousands of years. And that is where its beauty lies. It is an act of ultimate hope. It is saying, we will not see this, but someone will. And that is enough. As we reflect on the possibility of transforming an entire planet, one final question emerges, a question about the deeper meaning behind it all. What does Mars teach us about ourselves, about Earth, and about our place in this vast universe? Earth, the blue and vibrant planet, overflowing with life, alive with birdsong and the rhythm of ocean waves. And then there is Mars, silent, deep red, lonely, yet filled with promise of what might be. These two worlds are not just rocks drifting through space. They are mirrors, each reflecting a different side of the truth. So what have our discoveries on Mars taught us about ourselves, about the meaning of life, and about our place in the universe? From the red dust to the way time seems to stretch, from vanished water to hope for the future, all of it blends into a deeper understanding. The first lesson: everything changes. Mars was not always the deadly red desert we see today. It was once warm. It once had water. It once may have been capable of supporting life. Then, over billions of years, everything changed. Its magnetic field faded. Its atmosphere escaped into space. Water evaporated or froze. A living world became a dead one. This is a powerful reminder: nothing is permanent. Even planets have lifespans. They are born, they grow, they age, and they die. And Earth? Our Earth is no exception. It is changing too. The climate is shifting. Species are going extinct. Ice sheets are melting. Not over billions of years, but over decades, within our own lifetimes. Mars is a warning. It shows us what can happen when a planet loses its ability to sustain life. It is a possible future for Earth if we are not careful. Mars teaches us to cherish what we have. Every breath. Every drop of water. Every moment under a blue sky. All of it is unimaginably precious. The second lesson: life is rare and wondrous. We still do not know for certain whether Mars ever hosted life. But the fact that we have to search so hard, that if life existed it was rare, hidden, and difficult to find, says something profound. Life is not guaranteed. It does not automatically appear wherever there is water and energy. It is a special, complex phenomenon, and perhaps extraordinarily rare. Think about it. Among all the planets, asteroids, and moons we have studied in our solar system, hundreds of worlds, we have found abundant life on only one, Earth. There may be microbes on Mars. There may be simple organisms in the oceans beneath the ice of Europa. But so far, we have found nothing. Earth, with all its astonishing diversity, from bacteria to forests, from insects to blue whales, remains the only oasis of life we know. This is not a reason to feel lonely. It is a reason to feel special, and responsible. Mars reminds us that life should never be taken for granted. Every species on Earth, from the Bengal tiger to the honeybee, from the Amazon rainforest to the Great Barrier Reef, is part of an irreplaceable cosmic legacy. When we allow a species to go extinct, we do not just lose an animal or a plant. We lose a chapter of the story of life, a story that may be unique in the entire universe. The third lesson: we are more capable than we think. But Mars teaches us something else too, something hopeful. It teaches us that humans are capable of doing the unimaginable. Consider this. 100 years ago, we did not have airplanes that could cross oceans. 50 years ago, we set foot on the moon for the first time. 10 years ago, we believed rockets could only be used once. And now? Now we are seriously discussing transforming an entire planet. Becoming a multi-planetary species. Bringing life to places where it has never existed. Mars is a challenge. It says to us, I am here. I am difficult, dangerous, and distant. But you can reach me, if you are smart enough, brave enough, and patient enough. And the remarkable thing is, we are doing it. Probe by probe, experiment by experiment, discovery by discovery, we are getting closer. The fourth lesson: time is longer than we think. Mars also teaches us about time, not time measured in seconds or minutes, but geological time, cosmic time. Close your eyes for a moment. Try to imagine 1 billion years. Not 1 million. Not 100 million. 1,000 million years. That is how long Mars has been dead. 1 billion years of silence. 1 billion years of wind sweeping through empty valleys. 1 billion years of sunrises and sunsets with no one to witness them. In that context, the entire history of humanity, from the first caves to modern spacecraft, is a blink of an eye, a fleeting moment. And yet, in that brief moment, look at what we have done. We created art, music, and literature. We discovered the laws of physics. We cured diseases. We flew to other planets. Cosmic time makes our daily worries feel small. Our arguments, our disagreements, our fears, all of them shrink against the backdrop of billions of years. But it also makes every moment of life more precious. Because we know that time is limited. Not just for individuals, but for species, civilizations, and even planets. The fifth lesson, we are all connected. Perhaps the deepest lesson Mars teaches us is about connection. When astronauts look back at Earth from space, they often describe an overwhelming sense of unity. From orbit, you cannot see borders. You cannot see countries. You see one small, fragile planet glowing in the darkness. Astronaut Ron Garan, who spent 178 days in space, described it this way: when you look at Earth from space, you realize we are all riding on the same spaceship. There is no them, only us. Every problem on Earth, poverty, war, climate change, is a human problem, not the problem of one nation or another. And when we look farther still, toward Mars, that feeling becomes even stronger. Mars reminds us that we are not just citizens of a nation or a continent. We are citizens of Earth. And perhaps one day, citizens of the solar system. The first settlers on Mars will not ask whether they are American, Chinese, European, or African. They will simply be human, a species working together to survive in a harsh environment. Mars could be what unites us. A shared goal large enough to rise above our small disagreements and remind us of what we share. The final lesson, hope is a choice. Take a deep breath. Feel the weight of all of this. The lessons about change, about the rarity of life, about human capability, about time, and about connection. But there is one final lesson, perhaps the most important of all, hope. Mars is a dead planet. It lost its atmosphere, its water, its ability to sustain life. And yet when we look at it, we do not see despair. We see possibility. We see a world that could be restored. A world that could be transformed. A world where life might bloom again. This is not denying reality. It is choosing to see potential in the darkness. It is choosing to believe that better things are possible. Carl Sagan, in the final years of his life, knowing he was nearing the end, wrote, "For me, believing in Mars is an act of hope. It is believing that the future can be better than the past. That humanity, with all its flaws, is still capable of extraordinary things. That the stars are not just distant lights, but destinations. Hope is not ignoring problems. It is seeing them clearly and still believing we can solve them. It is looking at a barren desert and imagining a garden. It is looking into the darkness and imagining light. And perhaps that is the real reason we want to go to Mars. Not just for science. Not just for survival. But because it represents a fundamental hope, that we can go beyond our limits, that we can create something new, that the future can be better than the present. The journey ends, the adventure begins. Open your eyes. Look around you. You are still here, on Earth, in your familiar space. But something has changed, has it not? You have traveled to another world. You have seen the deepest valleys, the tallest mountains, the deepest mysteries of Mars. You have learned about lost water, about time moving differently, about the challenges of living on an alien planet. But more importantly, you have learned about yourself. About your place in the universe. About your responsibility to your home world. About your ability to hope, to dream, to imagine a better future. Mars is still there, distant and silent, waiting. Waiting for those brave enough to make the journey. Waiting for those wise enough to learn from the mistakes of the past. Waiting for those hopeful enough to believe a dead world can be reborn. Perhaps in your lifetime, you will see the first human step onto that red soil. Perhaps you will see the first images of a sunrise on a new Martian day, captured not by robots, but by human eyes. In that moment, something will change forever. We will no longer be a species confined to one planet. We will begin to become what we have always been capable of becoming, a species of the stars. But that journey begins here. Here on Earth. With every action we take to protect our environment. With every choice we make to cooperate rather than conflict. With every moment we choose hope over despair. Mars is not just a destination. It is a mirror. And what we see in that mirror, change, loss, but also possibility, hope, and renewal, depends on us. The future of Mars is beginning right now. In the minds of children who look up at the sky and wonder. In the hands of scientists working tirelessly. In the hearts of those who dare to dream big. And maybe, just maybe, that future begins with you. Our journey through the mysteries of Mars has come to an end. But the story, the real story, is only just beginning. If this video touched your heart, if it made you more curious about the universe, if it made you look up at the night sky with a little more wonder, please tap the like button. Subscribe to the channel so you do not miss our next journeys through the mysteries of the cosmos. Every subscription, every like, is your way of saying, I believe in curiosity. I believe in exploration. I believe in the future. And I want to ask you something. Where are you right now? What city are you listening from? And more importantly, what time is it for you? Are you listening at sunset, when the light turns warm and golden? Or in the middle of the night, when the world is quiet and the stars shine brightest? Leave a comment below. Share where you are and when you are listening. Because every time someone listens to a story about Mars, anywhere on Earth, in any time zone, we are all connected by the same curiosity, the same sense of awe at the universe. Now, as you prepare to continue with your day or your night, let me leave you with one final thought. Tonight, or tomorrow evening, step outside. Look up at the sky. Find a faint reddish point of light, that is Mars. It may be dim, but it is there. A real world, distant yet reachable, waiting for us. As you look at that red dot, remember that you are not just looking at a planet. You are looking into a mirror reflecting our past, our present, and possibly our future. You are looking at the hopes and dreams of generations of humans who have gazed at the sky and wondered, what is out there? May you dream of distant worlds. May you reflect deeply on your place in this vast universe. May you always keep your curiosity, your sense of wonder, and your ability to see beauty in both the smallest and the grandest things. And most importantly, may you always have hope. Hope for Earth. Hope for Mars. Hope for yourself and for everyone you love. Thank you for being here. Thank you for listening. Thank you for being part of this extraordinary journey. From a small planet orbiting an average star on the outskirts of an ordinary galaxy, I wish you peace, joy, and incredible adventures on the road ahead. Until our next journey through the mysteries of the universe. Goodbye, and keep looking up at the stars.